Great. Let's start. Can you walk me through your teaching experience? Which grades and topics have you taught the most?
Sure. So I have been a middle school mathematics teacher for 3 years now. Before that, I completed my B.Ed from Mumbai University. I have been teaching in Poddar School for the last 3 years.
That's great to hear. Can you tell me more about the specific grades you have taught and the topics you have covered the most during your teaching career?
Sure. So basically, it's the sixth, seventh, and eighth grade. However, I have taken a few classes with ninth and 10th grade as well. And it's the usual topics: algebra, number systems, geometry, some early parts of statistics. I have covered these most.
Thank you for sharing that. Moving on to the next question. What is a common mathematical misconception that middle school students have, and how do you address it?
Can you give me a moment to think?
Of course, take your time.
So, a common misconception that most middle school kids have is that when they first learn fractions, especially multiplication as well as division by fractions, they are always taught that multiplication makes a number bigger and division makes a number smaller. But that is not the case. Basically, you like for example, 4 into 1 by 2 is 2, which is like smaller than 4. Similarly, 2 divided by 1 by 2 is 4, which is bigger than 2. So this is a common misconception that I face, especially when I'm teaching fraction, multiplication and division by fraction to kids.
That's a very insightful observation. How do you usually address this misconception in your classroom? Do you have any specific strategies or activities that help students understand this concept better?
Yeah, so actually you're spot on. We like more than activity, we take real life examples. So for example, the 4 into 1 by 2 example that I gave you, right? So for example, if I tell them that okay, I have 4 slices and I take half of them, how many are remaining? So the answer is two. Two are remaining. So it is very important to build this intuition in kids that okay, what does multiplication mean? What does division mean? As well as what exactly are fractions? What are the real life implications of them? So activities like these help kids out. However, it takes some time. So if you want to think that okay, in one class this intuition will build, that will not happen. You have to build it over time by constantly talking about this, reinforcing this in kids.
That's a thoughtful approach, using real life examples to build intuition over time. Thank you for sharing that. Moving on to the next question. Can you give an example of an interactive or inquiry based lesson you have conducted in the past?
mm, Basically an activity in class, right?
Yes, exactly. An activity or lesson where students were actively involved or explored concepts through inquiry.
Sure. So I think one activity that I really like is when we are introducing circles in grade six mathematics. At that time, we teach students what is pi, and the diameter is 2 pi r, the area is pi r square. So before doing that, the one activity that I always do is basically we take different circular objects, might be a kada, might be a ring, might be a glass, might be a hoop, and basically we take a thread and a scale and we measure. Like I teach them what is the diameter and what is the circumference and what is the diameter, and they basically write down for different objects what is the circumference, what is the diameter, and then I ask them that okay, do you see a pattern if you divide c, like circumference by diameter? And that is the first time when they discover that okay, regardless of the size of the object, the ratio of c and d is same, and that is how we introduce pi. So that is an activity that I always like doing, because the kids are often astonished that this, like even if like the size of the circle changes but the pi does not change. So that's, yeah, that's an activity that I really like.
That sounds like a fantastic and engaging activity. It must be exciting for students to discover the constant value of pi on their own. Thank you for sharing that. Now let's move on to the final question. You have a long rope that you are cutting into smaller pieces. Every new piece is 1 meter longer than the last. After you are done cutting, you observe that you have a total of 9 pieces. What was the length of the original rope?
Okay, okay. Can you please repeat the question? I'll write it down.
Certainly. You have a long rope that you are cutting into smaller pieces. Every new piece is 1 meter longer than the last. After you are done cutting, you observe that you have a total of 9 pieces. What was the length of the original rope?
Got it. So basically, this seems like a AP question or progression question. Like the if the difference is 1 meter, then basically, like it's causing an arithmetic progression with like 1 meter difference between different parts. Like the shortest the length can be, I'm assuming it's 1 meter. So let's say we start with 1 meter and we keep adding. So basically, the pieces are one, two, three, four, so on. This basically is a sum of sequential natural numbers. I'm sorry, what was the like how many pieces did we end up with?
You ended up with a total of 9 pieces.
Got it. So this is 1 plus 2 plus 3 up to plus 9. So if I do that, the formula is n plus 1 by 2. So that will give me uh, 9 into 10 by 2, 45 meters, 45 meters of rope.
Thank you for your answer. That was well explained. I appreciate you taking the time to answer these questions. Do you have any questions about the company or the role?
No, I think I don't know. I don't have any questions.